Morning, good evening, and good afternoon, wherever you are, and you have connected from a session on building cloud native apps on Azure. Tonight, we are exploring how you can build your container locally and then you deploy directly to Azure using a Azure App Service. Using Azure App Service, they're providing as a platform as a service provider. Without being said, let's start the agenda first. So, kind of introduce myself. I am Saim Safdar, and currently doing a dev. I am currently working as a DevOps engineer. I'm currently working on the Docker containers and Kubernetes service meshes a lot. And also, I'm very happy to be an open source contributor of some great projects like Ortelius and Layer 5. So, Ortelius being an open source community that's building project called Deploy Hub, and that's doing some kind of a microservices things out of the box. They give you the extremely easy dashboard, give you the some visual topologies of how the microservices are connected with each other. And there's a project called Layer 5, is an open service mesh community that's building service meshes and give you the extremely great visibility of running the service meshes and give you the insights of how the service mesh behaves, how they operates, how they functions, how they operate in these use case scenarios. And these are very good, cool projects, and everybody love to be participate in that. And also, I'm running a community called Cloud Native of Islamabad, and I'm a community speaker. They're doing a lot of stuff on spending workshops for in microservices and in like DevOps, cloud native, and microservices kind of a things. We're doing some continual workshops on these new technologies as they evolve, as they mature, as the people are using these every day as a bite. So here's a kind of a small introduction of mine, and let's start the agenda of today's session. And this today's session is sponsored by the Cloud Native Islamabad, and you can find about Cloud Native Islamabad on community.cmcf.io/. Cloud Native Islamabad, and you can also find Cloud Native Islamabad doing great, pushing great articles on LinkedIn and Twitter, on their Twitter handle Cloud Islamabad. So you definitely engage with them, and you can learn a lot of cool stuff there. And we have to communicate. We want to be in everywhere. That's why we're on Instagram, and we have also dedicated Discord channel as well, where the DevOps and cloud native experts doing great kind of expertise for as I mean, it's a Q&A, and so you do want to say hello to each other and get connected and ask them what you are doing in these domains. And if you got up in a problem, there are plenty of people around in our Discord channel. They would love to help you. So I loved everybody to be take part in it, and which send these all the links that are available in the description of this video in the YouTube that you are listening from, and you can find them, get connected, and you stay up to date on these cloud native technologies as well. So here's some kind of a GIF there. We have right about 14 or 15 members that's love to help you, and we kind of call and we are get connected with each other, throwing stuff, continuing building some online and virtual workshops for our community so they can learn cool stuff from us. So everybody stay connected in our Discord Cloud Native Islamabad channel, and you get up to speed on DevOps and cloud native technologies. So here's just some kind of a cool logo over there. It's not a pretty, but we want to get you out of the look of we are doing some kind of a microservices and cloud native things. It's not a pretty logo, I guess, but it's a kind of gesture that's what the community is, what they aim for. So as I'm learning the cloud native and DevOps technology, so I kind of set the agenda here because these technologies that we are learning these days and want to take participate in any kind of a way or building projects in these cloud native and DevOps technologies, they have a very steep learning curve. So I want when I started learning these kind of a terminologies, I'm really confused. And this is my first journey, look really, really scary. So where to start, what to do, what these technologies are, what their use cases are, is there they are the enterprise grade or for the startups, or what are the ways I can learn about these technologies, because these are the steep learning curve, as I said here. So what I have the agenda here, that I want in our community they can get familiarized with the languages that are used globally in the IT spectrum. So let's say people are talking about cloud native, Kubernetes, Docker, service meshes, Prometheus, Grafana, Knative, Rancher, or any other kind of a cool project that are existing today, and people are investing a lot of money, a lot of time in there. So I want that our community members get the feel, if they've heard about this term, they get to know what these technologies are and why the people are using and why they are investing time in it. So these are the core and core essence of our cloud native Islamabad as a community. So these are, and as is a major points that we have built the community that can help you learn this language that people are using, and you are literally confused by the terms they are throwing towards you. So this is the core essence of first goal of our cloud native Islamabad, that you get to familiarize the languages people are using these days. And also the next term, so there are so many kind of a good and modern tools are here, and in the DevOps in a culture and a DevOps transition that is happening right now, they are around about 200, 300, or probably thousands of cool projects, thousands of cool tools that help you in building your cloud native microservices Germany up to speed, up to great speed. So what our community as their goal is, we want that in our community learn what in the globe people are using to run their businesses using their modern languages. And also, as a humans, we tend to do mistakes, and we learn from the mistake. Either we learn from mistake that we do or somebody else do. So we want a sharing of some use cases, some success stories around the world, engage people from different geography, different part of the globe, and they kind of give you the insights of what their success stories in using DevOps and cloud native on the way. And also, you see there are so many trends going on. So we want you to get up to speed on to know what these trends on, and these trends help us predict the future of IT. So these trends are really important, and you want to get really early in these trends, because if you want to be in late in these trends, you might end up stay behind with other communities and other people's working in your organization. And also, there are enterprises that loves the DevOps and cloud native tools. And if enterprises love these tools, they want somebody have skills, have empower in that, so they can a good fit for their enterprise grade solutions, like enterprise in their company, in their organizations. So, and if as that happen is going so fast, so people are really want where to learn these things. How can I learn these things which help me stand out in the community and organization? So these are the really things that I understand, as our community understand, are the basic things that the community should do for their members. And we are really, really happy that we have constructed these core concepts and now building our community in part of these concepts, part of these things that I want our community to learn and grow and be a standout in rest of the community, in the and you want to be stand out within the community, and you want to be stand out within the organization by learning these tools, by learning these languages that people are using, by learning what the enterprises are looking for, so you get up to speed on your dream job. So apart from that, we are also looking for this, because software and the business is not always about successes, but it's all about suspenses as hiccup. And when that happens, where is to look for? So you are gooding, and also, so there are so many good things you can do, but really, narrow minded These are only people that know you very well and you are very good at these things, that are living with you, living alongside with you. But the rest of the community doesn't know what are the good, where are you good at, and we how somebody else can take the advantage of what you learn over the year, and what you learn over the years, and what you build a skill around you, and you want to help each other. So this is the community for you, so you can help each other on doing some kind of thing. And also, this is a question that asked by many, my friend asking me, that there are virtual events are going everywhere. So why not, where we are living, why not we doing some kind of activities around these? Because we have to do that, because cloud native is ever evolving, ever growing, and DevOps also ever evolving, ever growing, and microservices is also ever evolving and ever growing technology and a community. So what we do now? So we want to take advantage of these virtual events that helps you showcase where to go for and how to learn these kind of things. So we have kind of figure out these are the constructs that we need to build. We need to build a community around these our points, so people can get up to speed on latest modern and cloud native technologies. And also, the great things that I learned in working in the communities part, that some organization need an experienced person. You are so tremendous, so intelligent for the rest of the people, but you doesn't have experience around you which help you get you up to speed on your dream job. So in that regard, what you should do, so communities are there, so you can gain the experience from the communities working there, and you can showcase what you have done in the community, and show to the people, and show to your dream job recruiter that I have done in the past these kind of activities. So you can learn that you are very passionate, very great at these kind of things, and you are passionate about learning new things, and passionate about learning some kind of a cool stuff. So this is one of the best goal, one of the best things that the community would offer for you. And there is so much more that the community can offer, but at least you can get the experience that you do not have. But in indulging with communities, you should have some great kind of experience, so that you can showcase them, and you can get your dream job. And also the most important part of learning, if you help other to learn, indeed in most of the cases you help you learn, because as you learning, and as you portray your knowledge and skills to the community, you can know what I have learned has some feasibility around their in the community and in the organization, or not have. So this is a great point. You can learn, you can portray your knowledge, and somebody else watches you, somebody else listens to you and asking you question, and that helps you learn in the longer term. So these are the core concepts we figure out for as a community you should have. So Cloud Native Islamabad is based on that community, and we love support from other peoples, we love support from our community and around the communities, so they can help us grow and we can help them grow. So that's a core part of it. So now move to the what the community is have. I think if you in the virtual events these days, you should know the events are going on everywhere in the globe. Wherever you are, there is something virtual event is going on in every day, in every 6 hour, in every month, on every year these days. And especially in the coronavirus situation, these virtual events are going in every week, in every part of the world, in somewhere. So these events helps you, and you have the knowledge of some kind of, let's say you are a Kubernetes or Docker expert. Now you have the knowledge, so you can grow. And we also know that the Docker and the Kubernetes are kind of revolutionize the IT, and they are everywhere in the globe if you are working in the IT sector. Docker, Kubernetes, and some other tools, they are everywhere wherever you are in their geography, because these are the really technologies that helps you a lot. So how the communities help you? Let's say you have a Docker and a Kubernetes developer. So now you have expertise. Now you can go to the other parts of the world and showcase your knowledge in these kind of a thing. That's I am learn over the year. Showcase their stories. Showcase how you learn these technologies and help them help them to help other people how they learn these technologies. So communities help you to stand out within the community, and now you can go everywhere and you can portray your knowledge in other parts of the geography as well. So there's communities definitely helps you in doing some kind of a things as well. And also this is a great event coming on, is the KubeCon and Cloud Native Con that's happening two time in a year. It's now second time virtual. It's the first time virtual KubeCon EU that happened in might be in August of mid of August or last or the end of the August that's happening, and that's a very cool event that I've attended and I've done so many cool things. So it's new, and another KubeCon and now Cloud Native Con is going in around our corner, and it's happening in the mid of November. So everybody should able to attend at least. And if you attend, there are so many people are surrounding the world, and I know by attending the KubeCon and Cloud Native Con, the companies, communities, organizations, startups are everywhere around the world are going to be there. So you can learn from there, and also if you learn something great at it, might be in the next Cloud Native KubeCon, you are doing the stuff and we are watching you, and that's mean you're doing some kind of a speaker's role as well. So these are the I would love these kind of event. I hope you love as well, because they help you learn some cool stuff around the world. So also, what are the ways to stand out within the organization, within the communities? So what I said because I'm spent so many time in Docker and Kubernetes. So when I spend so much time, so I want how I stand out within the community, within the organization, as a cloud Kubernetes expert or some kind of that kind of a role. So this kind of a certification, like we have a certified Kubernetes administrator exam that help you not only stand out within the organization, within the community, but also in the globe. And if you are certified person in that, people are love to engage with you and love to learn, love to ask you what you have accomplished over the year. Let's work with us and help us how we adopt the cloud native technologies. So these exams are Kubernetes. I have two of them: certified Kubernetes administrator and application developer. And these help you stand out within the rest of the community, rest of the globe, and rest of the organization with other peoples are working on beside you. And there's another certification that's coming up that's called Certified Kubernetes Security Specialist, that going to be after the Cloud Native KubeCon and Cloud Native Con. You be able to because this new certification has been launched in last or might be the mid of December. After they introduce at the KubeCon and Cloud Native Con in the new certification, and you would be up to speed. If you have these three certification under your belt, you are really you have spent your great time. If you have certified in these, if you achieve these three certification, that's mean you spend great time learning great things, and that's definitely help you going forward. So as to recap what I have just said, so we built a cloud native Islamabad community that was core concept that helps you learn the language that the rest of the globe and the rest of the people are using in order to be effective in your domain, in your organization, and within your community, and within your geography where you are living on. And Also, if you want to stand out for the rest of the community, these are the certification I definitely recommend everyone to be take part in it. And that's good thing around that is because if you fail from these kind of exam, at the end of the day, they helps you learn so much thing, because I have learned by doing these kind of learning activities on these kind of technologies, and these certified exam definitely helps you stand out within the within your organization and within your community. So everything just said, hope that keeps motivated you, helps you motivate, keeps you motivated on cloud native technologies. So let's send the agenda of today's session. So we are here learning cloud native apps on Azure. We build the Docker container today locally in our Docker machine, in our local machine, and then eventually we deploy that container to the Azure. And also, this is the part one. This is part one. We build a series around cloud native apps on Azure because I have learned that there is so much cool stuff you can do in Azure. I have spent time in Azure a lot, so that's I have some kind of that's might be a give me the edge of working on cloud Azure previously before. So I have now know how cloud native helps you in Azure as well. So we build a series around that. The first series we take a simple tiny app and deploy and build on our machine and eventually deploy to the container, deploy to the Azure. So if we want to deploy into the Azure, we need their container registry. So there we use to know what the Azure container registry are. And if you want to deploy in every Azure container on Azure, how you should do that, and that there we'll learn about Azure App Service and web app for container, a lot of cool stuff there. For the next series, we deploy everything from Docker to Azure. Without going to the Azure plate or Azure board, we are simply using the Docker CLI command and pushing containers to the Azure Container Registry from Docker CLI, and it's creating the under the hood, create the resource group and creating the deployment plan, creating the container registry, everything, and we just deploying the containers using the Docker CLI, and they are abstracting the ways that we should usually do in Azure in order to deploy our app into the Azure. And that is our part 2, that state Docker to Azure using ACI integration, Azure Container Instances, where ACI means. And for the third part, we are deploying apps to Azure Kubernetes Service. There we also deploy as tiny apps, and look how the Azure Kubernetes Services helps you get up to speed on cloud native on Azure. So these are the 3-part series that we are going in our next session. So let's set the agenda first. Tonight we'll learn the Azure. If you haven't heard about Azure or heard about anything anything about cloud computing, don't sweat. We are here to help you. So what waste time, try to spend few minutes on understanding the core concept of Azure, and we are next spending our times on learning containers. So if you doesn't heard about what the containers are, we are just spending few minutes, if you haven't heard about container, to get up to the field what containers are like. And when we look at the Azure and container, the next step is we're building the Docker images, the Docker containers locally, and running them locally in our developer or a dev machine. And once we have done with that, now we should do a plan how you should deploy into the Azure. There we see a Azure App Service and learn about the plan of different plans in Azure. And once that's we have the core concept, everything we have learned about Azure containers, running them locally. We have a Azure App Services. It helps you deploy containers in Azure. Now we are good to go to deploying container to Azure. So really quickly, what is cloud computing? Because if you're working around any cloud providers on Azure, AWS, or Google Cloud, or Oracle Cloud, or IBM Cloud, the first thing you need to know what the cloud computing is. So in the dictionary, this is the term you have to see. The practice of using the network of remote server hosted on the internet to store, manage, process data rather than local server or personal computer. What that means is that you have some kind of a dedicated server service that is not on your computer but is elsewhere, and you are using their resources on, like they're using processing like storage, compute, on multiple things around that. And what a cloud computing from the DevOps, a cloud native engineer and system engineer or cloud engineer perspective. So there we think, let's say we have an on-premises environment. There we have an infrastructure that our team builds and our team are maintaining every day. So what the things we are looking for? First, we own this. We are own all the servers that are reside in our real estate. Then we hire the people that know these servers how to maintain and operate, and we pay the rent with their server or livings, and we pay the rent and real estate for that. And we also take all the risk, because if one of the server is caught up by fire, we replace him with new one, and we do all kind of these kind of risk and activities in if we are doing that in our own premises environment. Let's say what the cloud provider doing here, how the cloud provider doing this kind of activities. Now somebody else on the server, you don't manage two servers, and somebody else hire the IT people which knows how the servers manage and operate. Somebody else pay or rent the real estate. Somebody else take all the risk if something goes bad at it, and you are just responsible for configuring your app on cloud services code, and someone else take care of the rest. So this is the terminology. If somebody asks you what is cloud computing, I think if you are a DevOps engineer or cloud engineer, these are the things that you have to know, that you are now no more managing the server, the IT people who knows how to server manage and operate. You don't pay the rent or real estate. You don't take the risk. You are just responsible configuring your code, configuring your services inside the cloud provider, and they're doing all the rest for you. And you are very good at it, and you are good up to speed on using cloud if you are using cloud provider. So this is the term that I learned over the year, what the on-premises mean and what the cloud provider means. Also, what is Azure now? So Azure is a Microsoft called the cloud provider service, a microservice at Microsoft Azure, and commonly people refer to as just Azure, and we all use Azure most of the time. And so also people also use this kind of a term a lot for the clouds, for Azure and AWS and other clouds. So they call that cloud service provider, and can be initialized as CSPs. Have you heard a lot these kind of a terms? But what do you think the Azure means in the dictionary? So I am really confused about the time what the Azure mean actually, and trying to know in this very few time I've learned that what the Azure mean is literally the bright blue color of the cloudless sky. Yes, you heard it. Now, what is Azure? Is a bright blue color of the cloudless sky. And what is Azure? Azure is a CSP, a cloud service provider as well. But it's what it means, the bright blue color of the cloudless sky. So now we have to understand what the cloud services are. If we are using any part of cloud services, we are just using these term globally, because not the Azure, they are not only the Azure providing these services, but AWS, Google Cloud, Oracle Cloud, and IBM Cloud, they are doing the same thing, but the core thing they are providing us as an infrastructure as a service kind of capacity. So what a cloud service have 100 and 1,000 of services, but the four most common services that the infrastructure as a service would need is called compute first. So imagine you have a virtual computer that can run applications and program and code of the other people's. And next thing, when you deploy the apps on compute resources, next thing that logically comes into our mind, how to communicate networking around that. So there we see, imagine you have a virtual network being able to define internet connections and network isolations. sorry. So imagine you have a build a networking around that, and now you are using the compute resources, your apps are running on that, and people and these apps are need some kind of a networking. So now you have a virtual networking capabilities available, and every app needs some kind of a storage. So imagine you have some kind of a virtual hard disk that's going to store files, retrieve data from there, and all good cool kind of a things here. And next, the core part, you have some kind and databases. Every app, most of the app and enterprise app mostly need databases. So imagine you have a virtual database that services consume and retrieve data from. And these are the core terms I've used. But the cloud computing term can refer, the term cloud computing can be used to refer to all categories, even though it has a compute in the name. So it's not about just compute. It's all about all the things that your application needed in order to deploy, in order to be customer using these 24/7. So what are the benefits of cloud computing? First, the foremost, it's no upfront cost. As you're consuming your services, you pay the rent for it. So let's say today your application user are 10, you are using 10 people for, you are using the cost, or you are just going to be giving the cost to the cloud provider of the 10 people. And someday your app scales and now it's have 100 people. Now you are consuming the services what they are using in order to satisfy the requirement of 100 users, and you are paying these kind of resources in Azure for you. And also, if the scale go back down and go back to 5, and now you are just paying the resources as the 5 user are using. So that's a pay as you go model, gives you the extra flexibility, extra tuning of your resources. And also, let's say you have an application that is built on, you are built now, but you want to be hosted for Australian or North Americans user. What you now do, you go to the cloud provider, use a region of North America or Australia or Asia, their application are going to be hosted on, and you are get up to speed, and cloud provider instructed away how they where the infrastructure they are putting on their Asian geography or North American geography. You're just putting the resource where you want it to be. And third, now the most important thing, you don't have to worry or even plan about the physical security. If you manage the server, you have to think how to secure the server. What if they are caught up by fire? What if their cooling system is going down? So now you don't have to plan, you don't have to worry about, because cloud providing doing all these things from you. And also, let's say your app is down, your data is some kind of a geography, let's say disaster happening in some kind of geography, and you lost your data. What happening there? So cloud provider give you the disaster recovery, replication, fault tolerance, all kind of these buzzwords for you, and you don't have to even worry or even plan about these kind of things by you. And lastly, they can increase and decrease resources on demand. Let's say you have a Black Friday or a Halloween coming up, and your users are spiking and the resources are spiking, and your application is going crazy at using the resources. But what if the demand is going decreases, spike goes down, it's eventually decrease the resources that your app consuming right now. So your billing is not going to be surprise you at the end of the week. So, and also you can automate the scaling and spikes of your demands with just a little as cloud, let's Azure templates, cloud formation templates, all these things, all these kind of a good thing. You can automate the entire scaling, scale up and scale down process for you. And lastly, and most importantly, you don't have to worry about planning your hardware, planning to fix your hardware, or planning to fix your operating system, your software that operating system runs, because these are the responsibilities of cloud provider, and they are doing that for you. But you have to learn and think about, if you need these kind of benefits, using these kind of benefit from cloud providers, you have to understand these kind of cloud computing models. The first is platform as a service, where you don't have to manage anything. You don't have to manage even your application. It is a product that is managed by service provider, and you don't have to worry about any services they run and any infrastructure they are any infrastructure your apps are using to run on. So the most primary example of software as a service is Gmail, Office 365, Salesforce. So these are the really common applications that are used every day, but at the end of the day, they are the software as a service model, and these are for the customers. For the next, we have a platform as a service model, where you don't manage the hardware, you don't have to manage the operating system, but you have to configure your application, and you have to configure your application and what your application needed in order to run on that operating system. And that's kind of a service is called operate platform as a service, and that is for developer that we are building applications on. So let's say I have application that is running in Java, and we have a dedicated hardware for you. I have a dedicated Linux system for you, and now I just configure my Java app to run on these platforms. So these kind of services are called platform as a service. You have a Heroku, Google App Engine, and Azure has so many kind of a construct for platform as a service. And lastly, infrastructure as a service. So Microsoft Azure, AWS, Oracle Cloud, Google provides are at the end of the day is as infrastructure as a service for you, and that's for admins that are managing and operating the infrastructure for you, and you don't have to worry about the RAM, disk, compute, and storage of these kind of things, because these are doing for you by these are giving you by default by the cloud provider. You are just need operating system, and that operating system you have to manage now, and you don't have to think about how the hardware running underneath that. So we learn about cloud computing, cloud types of cloud computing, benefits of cloud computing, and the last thing and the most important thing that I want everyone to should know what the share responsibility model are. Because we are building apps on cloud, building our cloud native apps on Azure, we have to understand what my responsibilities are and what cloud provider responsibilities are. So in order to I fulfill my requirements, fulfill my everything what my apps needed. So that's the share responsibility model is really important for everyone. So I have show you what the customer is responsible for. That's mean I am responsible for what and what is Azure is responsible for. So these are the two different colors that shows you where you are responsible and where your Azure is responsible, where your cloud service provider is responsible, and these share responsibility model are same regardless of whether you are on Azure, on AWS, or Google Cloud. So let's say you have in on premises, you have to manage your application, you have to manage your data, you have to manage the runtime your application needed to run that. Let's say you have a .NET Core application, you have the .NET runtime needed for you in order to build your application and deploy your application. So you have that responsibility to you have now responsible for runtime as well. You have also responsible for the middleware. Let's say the application needs some kind of authentication services there. Now you are also responsible for that middleware that are you using, and you also responsible for the operating system your app is running. You're responsible for virtual machines if you're using the virtualization technology to run multiple apps on single server. You are also responsible for managing the virtualization part. You are also responsible, and your team is responsible for managing or operating the server. Your team and your whole team is also responsible for managing the storage part, and your also whole team is responsible for managing the networking part. Let's say now you are going to use that infrastructure as a service model that's giving by the cloud provider. Now you have to manage applications, data, you have to manage runtime, you have to manage operating system, you have to manage, but now the virtualization part, that the cloud provider is responsible for you. For the server part, Azure is responsible for you. For the storage part, Azure is responsible for you. For the networking part, Azure is responsible for you. As you go to the Azure to aid as to PaaS model, now you are still responsible for managing the application and managing the data, but the rest is all managed by Azure, whether it's runtime, middleware, or operating system, virtualization, server, storage, networking. They're all managed by your cloud provider, Azure, in our case. And if you go to the as to PaaS to SaaS model, now you don't even to worry about how my application runs, how the application consume data. All runtime, middleware, operating system, virtualization, server, storage, networking, they're all managed by your cloud provider, as in our case in Azure. So let's the recap of the small what we have learned. We learn about what the cloud computing is and what the Azure is. Azure is at the end of the day a cloud service provider, and we learn the types of cloud computing, and we learn the shared responsibility model. That is very important for everybody to understand that. So let's now learn what the containers are, because in our cloud provider we use container, we host containers, we deploy our application inside a container, and that container eventually deploy into the Azure or our cloud service provider. So what the containers are? So back in the old days, regarding 200 and 300 years back, you have the problem of managing and shipping your products from one say source Islamabad to destination, let's say Karachi, and we don't have a sea in them between Islamabad and Karachi. The analogy not going to be fit here. So now let's change the analogy. Let's say we ship our product from Karachi port to might be the Gwadar port or somewhere else in the Iranian port or the Indian Ocean or some kind of thing. So how I ship my products so they can easily portable from one source destination. So humans tends to do amazing things all the times. We start our destiny of first we innovate the electricity, then we also innovate. And innovation is every century is going on. As the innovation happens, products are changed. So let's say I want to ship my sofa from, let's say, Karachi port to the Gwadar port. So what I do now here? So people really going to figure out there is no standard way so they can isolate the different materials and just ship them to the oceans. Let's say some products need cooling when moving from one place to other place. Some things need heating when moving from one place to other place. So you can't encapsulate two things in a one box that going to be heating and cooling, doing two things at the same time. So you don't have some kind of these kind of a flexibility when shipping your products from one stage to source to production. So there we see a container adoption in our shipping or some kind of a shipping industry or kind of a whatever you call this industry is. So what the containers are going to help us here. Container as a standardized way for us as a shipping company to package our items and to gather into one shipment. And what at the end of the day I get up, I have standard packaging. I need isolation and efficiency. Let's say one part of my product need cooling. Now I containerize that part in the container and it has cooling bit inside it. And one part it's have, let's say it's kind need some heating. So I am isolate that part in another container, isolate that product in another container, and they need some kind of a heating part. So now I have isolate my different products in a container. And what it means, one person is managing by putting things inside the container, and other thing is responsible for shipping container from one source to the destination. So we achieve portability, and also that we need separation of concern, because different containers may end up doing different kind of moving different kind of a things. When achieves separation of concern by using containers. So now understand what they are doing in our laptop. So what the virtual containers are. So for virtual containers, as application programmer, what they give you, the code, the configuration, the environment variable, the secrets, the server specification, everything your app needs are certainly inside the containers, and everything have going to be inside the container. And what your app needed, you containerize everything your app needed inside the container. And what that means is containers are the standard way for us to package our application, its configuration, its dependency together into a single logical object. And what they give us, the virtual containers, they give us a standard packaging system. Because let's say we have our app that needed Java, that's building on Java, and one app is building on .NET Core. So these using different configuration, different environment variable, different things. So we are now able to standardize our application and different containers in a different set of environment. And we also achieve isolation and efficiency by running our microservices app inside the container. They're using different technologies, different configuration, different environment variable, and we tend to adopt microservices construct by containerizing our apps. And also, one app person, let's say a developer, is containerize everything inside the container, and the DevOps person is pushing that containers to the destination where the customer are using that. And we also have a separation of concern of that. So what we achieve in the sea is now what we achieve in the ocean, what we see in the laptop as well. Standard packaging system, isolation and efficiency, portability, separation of the concern. So that's the containers are for our. So in order to understand what the containers are, let's say what the definitions of application are as to humans. So application is the software that programs that are developed to perform specific tasks and execute on a computer. So applications are literally just a program that are developed to perform certain tasks that execute on the computer. But how the computer interrupt this? For the computer, applications are just a binary, and the instruction for the computer for executing a task that run inside a process. So for the humans, application are the software that performs specific tasks and execute on the computer. And for the computer, programs are literally the executable or executable task that run inside a process. So just to hear, so the quick recap of how we're managing and maintaining our apps. Literally, in the past, we do our apps in that way. We have a physical server, and we have operating system over it, and then we have a hypervisor over it that virtualizes our hardware, disk, storage, network capacity, everything virtualizes, and then we install operating system that using virtual hardware, and then we run our apps on it. So in that process, we able to run many apps on single host, on single infrastructure, on single physical infrastructure or hardware, and that peoples are called virtual machines. And that's how the virtual machines are helping us by running multiple apps on single infrastructure by virtualizing techniques so that our apps using virtual machines in order to we can run multiple apps on single hardware infrastructure. So now we are evolving from that infrastructure. Well, what we say is, why not we run multiple apps on single operating system? We end up having the same hardware, same operating system. Now we replace the hypervisor with a container runtime, and we run and manage multiple apps on single operating system by using a container runtime. And that's system and that's technology is we got, and we love this technology a lot because it help us it's by uh, and give us the flexibility that we end up not managing and maintaining the virtual hardware or virtual machines that running inside our operating system, inside our hardware. So this technology is what we refer to as, what people refer to as, is called containers. So, so what I want to the give, what I want you to give home here is, so these are the technologies that we are building, that how our infrastructure is built and we run our apps, but they have the potential benefits and benefit or losses of these technologies. But for the containers, you gain so many things, and for the last part is not a loss at the end of the day by adopting a container technology. So these are the quick comparison of these technologies. If you haven't see, if you wondering how containers come to the picture. So in order to make containers real inside my developer machine, what I need are namespaces and control groups. So these are the really core concept of how the container behave under the hood, but I'm throwing these terms so you can understand how container eventually work inside the operating system by running multiple apps on the operating system by these two technologies that we call namespaces and control groups. So kind of a quick recap, let's say there are different processes running on your operating system. You want to isolate different processes. So what you do is that you need process isolation, or let's say file system isolation. There is so many things, but we are end up pretending here for just these two things. I need process isolation and file system isolation. So these isolation can be achieved by using namespaces. Namespaces is like is give you the house and members that are living inside that house analogy. Let's say you have a house, dream house, there your father, mother, and your two, let's say their children are living. So what children end up need isolation, and for the father, they end up need some kind of a control. They can see what their children are doing in this house, and for the children perspective, you don't, and they don't want to know what is happening rest of the house. They thinks they are the only members living inside the house, but for the parent, they see everything happening inside the house. They see the whole hologramic view of the house. So namespaces work in the same way. We want our operating system, our operating system can see every process that is running in our it, can see every process that is running our it. But for the containers, we want to see the only things that is running, containers are, we want the container to see only things that they are running. So what end up happening, we are removing the conflicts. In order to remove the conflicts, we need namespaces. So let's conclude the namespaces topic here. If you need to run the containers on your machine, you need Linux kernel feature plus namespaces. Namespaces give you the flexibility to remove the conflicts. And let's say control group. What control groups give us? So let's say what you have a process ID 9 is running in your operating system, and this needs some kind of a CPU, memory, IO, and these are the instruction how they're running inside the your operating system inside your hard disk or virtual machine, what is happening. So I want that process ID 9 is not end up doing consuming not so many CPU, not consuming so many memory. At the end of the rest of the processes go to the star. So we set the limit by using the control group. So these are the two terms that helps me manage the containers inside my, that helps me manage at the end of the day how the containers work. So the namespace gives the flexibility to remove conflicts, and control groups gives me the flexibility to limit the resources that container wants to be using. So these are the terms I think you have to learn in order to be effective in learning container technologies. So now what the computer thinks what the containers are. So literally for computer is nothing, it's just a process that has everything inside, and we encapsulate everything inside the container, and it's now anchored by namespace and controlled by C groups. So let's say it's a tarball that have everything inside it. Now for the computer, it's using the namespaces and control groups to run the controller in containers effectively and efficiently. So this is the app that we are building right now. It's a tiny app that we run our app locally, and then finally we deploy to Azure. What that has to do from is the first instruction that build the first layer of the node image that using the Alpine. So where this Alpine images come from? So I doesn't direct the registry here where the Alpine is actually living. So if I doesn't ask him what the registry is, by default is go to the Docker Hub and deploy the container image off of that. So it's first constructed the first layer that is having the node and Alpine image that by application needed in order to working properly. So let's say it's a web server that listen for the application and give a support where you want to see our application is running on. So that's a node Alpine first our image. And now next thing we set the working directory inside a container by calling user app. You can name it any way you want, but I said here user and app. Then I copy the package.json file from my local machine into the containers. So I have a user app, and then I have another directory that called app.package.json file. So what I next see, in npm install see the packages that I have in user/app inside package.json file, and they are pulling the dependency my app needed, and everything is now up and ready. So lastly, in the fifth layer, I put everything inside the container from my current working directory and going to jump to the container directory, and then we set a command npm start to build my application. So that's how containers are working locally. We have a container, or we have a Docker CLI or Docker CLI installed in my local machine. Then we have a container runtime, and then we have a container registry. So we have images, and then we have a containers. So for the build, first let's say we build for Docker run command or pull command or push command. What end up doing that the container runtime, if it first see, let's say I do have images in my local machine. If it doesn't have, it goes to the Docker Hub and pull the images necessary for my application to work properly and put them in my local machine, and then we end up running the container from that images. So let's start. The first thing is we're deploying containers to running our application locally. So here is my app that is now running. That's a very basic tiny app of a Node.js application. So first thing, I have grabbed the Node Alpine image, working directory setting. Then I uh, uh, put the package.json file that is here and put them inside the Docker container. Then we set up the command npm install, copy everything that is my current folder have that is here and put them into the container. So it's certainly what we see in the browser, that is say welcome to the cloud native Islamabad, and we have some useful resources for our community, and we also have it's running on the localhost 300, and we have a test is also running. This is we can't do neglect what the app is doing, but we want to show how the Docker how the container runs locally. So let's say first thing first, we build the Docker container right now. So let's say, so I have a Docker running locally, and what is if you want to install Docker, go to the Docker Hub, dockerhub.com, and you can grab the version that your operating system needs. It's a very standard installation and very easy installation for every operating system. And if you do end up caught up in surprising in installing the Docker, let me know in the comment. I would definitely help you out. But it's a very standard installation. So it's have a Kubernetes cluster inside it, and that's a great thing if you want to learn, if you want to test your knowledge of containers and want to work with Kubernetes as well. So, and it have a very cool feature that's coming up now. This can listen to the very great feature right now it's have. It's a new dashboard I personally love a lot in that Docker. So it's a Docker I'm installing, and now what I first thing is doing now, I build the Docker. I am in the current working directory where my Docker file is. So what I do, I build the layers that residing here in. So what say I say Docker build node Docker and demo, and I build the image and I tag it, and eventually I go to the period and I hit enter, and it detects the Docker file and is constructing the layers that my application needed. So it's first grab the node Alpine image from the Docker hub, and once it's all done, and then we are able to see our application is working locally, and eventually then everything going, we want to test that our application work properly, then eventually we deploy our application to Docker into Azure as well. So there, if we doesn't specify the registry, it's by default going to the Docker hub, and Docker, and you want to and Docker hub is kind of a GitHub of local images, images that are the production images that we have available in Docker hub, and these contain every Docker images that we want to need, and they are pulling right now, and then eventually that's the first layer is constructed. So that's a layer file system is end up good, is so great, so that let's say next time we build the image, our node Alpine image is not updated, working directory is not updated, we haven't edited our package.json file, it's have to be the same, npm install working directory same, but we end up doing a tiny changes here. So what end up doing here is only that part is changed, and the subsequent layer are absolutely fine. It doesn't change, so it's used from cache, so the subsequent build are really faster, and that's a layer file system we call out in the Docker. And also when the optimization I have in here, that let's say if I couldn't, let's say if I commit that, let's say I remove this kind of a line, what end up happening is its first node is first pick the Alpine image. Let's say it's using from cache. Next, working directory is the same. Then subsequently, when it doesn't and if I do that kind of a thing, copy first all the thing I have, then I install the npm install. What end up happening if I can do a change here in just code is again going to be install everything, but my package.json file hasn't changed. Every time I do a change, I run a build, it's going to be install npm install every time. But if I do a certain modification here, so what it's doing, I'm just installing package.json. So first set the working directory, install package.json file, and go to the container working directory, and it doesn't update. So it next time is don't install the npm packages for that. And next layer, we build everything inside it. So these are the small optimization you should do in order to build going to be very fast. So now we have our build is up. Let's say now we're going to go and see what our images are. Oh, and if I can type properly, we see our image that we are working around. So one thing, in order to run quickly, so now I end up doing contain docker run -d-p. Let's say we want to going to be 8080 and it's using the port 3000 and it has an image name is node docker and demo. And what I end up doing, I do in the detach mode. -d is doing for the detach mode. So if I'm not using the D, it put the entire logs of the container inside my this terminal, and I couldn't able to use that terminal again. So I asked them to doing that thing in a detach mode. Then I port forward again. I want to use the container 8080 outside, but inside the container they are using 3000. How I know? I'm going to the configuration config.json file, and there is a port where container the apps is needing. And also I set the container and node.docker. Now the UI give you the flexibility here, and now one of my container is running. I am simply go to the browser, and that is our application is running effectively inside in our local machine. So this is how our application is running in our Docker machine. So now let's go again. That's our tiny demo of running Docker container locally in our machine. We're running the Node Express app inside a container with Docker. So I give you the feel of how the container works locally with Docker. So there's not a Docker is essentially a container runtime that builds the images, pushes the images, and run the images. It's not the only one. That we have a Podman, we have a container runtime, we have a Cryo, and container D. But Docker being the most popular in this, but the other container runtime also have their use cases, and you have to be used in future as well. So now, how we deploy that we run our Docker container that is running our locally into the Azure. So there we have a Azure App Service plan. So it's a platform as a service model that enables you to host web apps, mobile backends, and REST API. So Azure App Service enables you to build and host, and it's a platform as a service offering from Azure, which give you the infrastructure and operating system, and you end up doing to host web apps, mobile backends, and REST APIs. So you have to choose if you choose .NET, if you they give you the flexibility of programming language of your choice. You choose .NET, you choose .NET Node.js, you choose PHP, you choose Java. It's constructed and runtime for you, and you just run your application for that. And let's say the Azure App Service give you the, let's say, Ruby on, if you want to use Ruby on Rails to deploy your application on Azure App Service, and this is no choice of that. You end up doing a containerized Ruby app running inside a container, and they give you the flexibility these days, and now you can adopt your you can run your Azure App Service. That's a very cool thing you can do with container as well. If you doesn't is Azure App Service doesn't give you the flexibility of running your application inside a container, because there's no container runtime for that in Azure App Service. No programming runtime for that. So you end up doing the containerize your application and run that inside the Azure App Service, and that's the because Azure containers or offering of Azure App Service. So, and how you want to deploy Azure App Service? You end up doing the zip file that's containing your whole application and deploy it to the Azure service. You can do that. You can do the file transfer from, let's say, local machine to the Azure App Service. You can view that from a local Git by pushing to the Azure App Service. You can configure your DevOps pipeline with Azure App Service by using Azure DevOps. You can do that using GitHub for that. Bitbucket, Dropbox, since let's say you can put the Dropbox file into the Azure App Service, detect it and deploy your app. So you can, there is plenty of model for that we have. So what we end up doing, and it gives you the operating system of your choice. Let's say you want to deploy .NET Core application, so you can end up like Docker on can run on Linux and Windows as well. But if you don't want to deploy .NET 4 framework, that can only be run on Windows. So it give you the flexibility and detect the runtime of your application, and if to ultimately deploy your application. So it gives you the flexibility on running on Linux and Windows operating system as well. So, and it's also has the Azure App Service plan. Let's say you build a plan in Azure App Service and end up containerize your Azure App Service, and you run multiple apps on single Azure App Service plan. Let's say we have 3 of them. And also this gives you the deployment slot. Let's say you have a development slot and you have a production slot. You test your changes and eventually you swap your deployment, and you can automatically rolling update of your deployment without even user affecting if user are using your application live. It gives them a rolling update kind of a scenario for you. So the user can have to see the new production by just tweening your version of deployment slot and production slot. So what I drive home here is the Azure App Service. You construct a plan, and inside you containerize your application inside a Azure App Service. Then we configure deployment slots for the dev and production scenarios, kind of a DevOps flow, and then we have a whole construct of running your app on single app service plan for that. So that's here we have that's how now we run, build and deploy Docker container to Azure App Service. First that we see up now, we develop a Docker image in our developer machine. Now we have a developer manage, have a Docker image available for that. It's containerize that we already do that, running container locally. And next we push that container image to the Azure Container Registry, and then the Azure App Service pick up the new changes that were done in the Azure Container Registry and deploy it to Azure App Service. So what the end up we doing, we have a DevOps flow is kind of that. Developer doing some quick changes in their code, build the image, build the Docker image by using the Dockerfile. And now it's have a container image available for them. And now it's deploying the Docker container image to Azure Container Registry. And eventually, when the new updates are going to be happen inside Azure Container Registry, Azure App Service pick up and deploy a new version of our application as the new changes coming up. So let's do that in Azure. So kind of a quick demo of what the Azure is. First, we need to create a resource group for that. What does a resource group does is, so a best analogy I can draw here is, so you have going to the let's say camping with your family. What you end up doing there, you need their food, you need to be there as a blanket if there is some winter going on, you need to go have a food available for you. So you everything that you need, you are containerized in a box or in a containerized in a car or jeep that you are driving from our source to go to the camping side. So that's the analogy with the Azure App Service. Whatever your app is using, it's we are end up doing to resource provide a container that's called resource group. And if someday we need to tear down that application, we just simply go to the resource group and tear down the resource group, and we do end up doing the nowhere of resource group. So that's the whole analogy. Let's give it a name of Docker demo. Let's say if it's accepted, validation process is going to be knowing. So now our Docker demo Azure resource is built. So next step is we have to have a container registry for that. Let's type here container registry, and we is first creating now a container registry. Let's create one here quickly. Let's say we already created a resource group. Let's put them in a Docker demo. So I give it a name of this one. Let's say if it pick up and I want my container to deploy on, let's say there's a locations might be Asia, North America, South America, where. So I want to deploy in West US. It doesn't know where my user are right now. So I just want to deploy it into the. So now just going to quickly create and going to that's container registry is creating. Is first providing the container registry. So if give me the container registry where I want my container to push through them. So I certainly push my container from there to container registry, and eventually I made an Azure App Service plan, and my containers are so it's thankfully going in very quick time. And let's go to the first go to the container settings of go to the access key. If I want and I have to enable the admin user access, because if I want to run the commands inside the container, I want these privilege for that. So first I have to authenticate it with that Docker login command to the registry. I want to have to provide a username for that. That is this one. Login with the login Azure Container Registry. So I get the name here from azure.acr.io that give me when I creating the Azure registry. I set Docker login with this domain name that give me the Azure Container Registry, Azure CI Container Registry.io, and then I providing the name, register, username, and I providing the password that given to me by the Azure, and I'm successfully logged in with that. So now very quickly I have to build the Docker builds and tag them by using this domain name. So I can easily deploy my Docker container, pushing my containers to Azure. So I first tag the Docker image, and then I use that name. So it's going to happen very fast because it's using everything from the cache. And now we just certainly push the Docker. Only next time is now we just need to push this image into the Azure Container Registry. So let's say we tag it by latest. So tag is a way of how to version things up. So let's say first time pushing the images. So and next time I do the subsequent update. So tagging help me. What are the most updated images you have? So it's asked me to tag the image. So because it certainly contain the repository of images is he have Azure should have. So I tag my images with the latest, that this is the latest image that everybody can use. And now I certainly can push this image. It takes some time to push that into the Docker image. It's pulling the 6 layers that we have available in our local machine, and when it pushes in the Docker Container Registry, when it's so it's pushing, when it's pushing successfully these layers. So subsequent model is that then we contain the Azure App Service plan, and that it can seize these Docker images inside it, and then we eventually whenever we pull the new image into that container registry, it's pick that up and deploy to the Azure App Service, and eventually that's our DevOps process began. So one of the very fastest they see this layer contains 101 of images, because this is the 5th layer of the app that we are using to install the npm packages. So it contains so much when updation of that. That's why that's the most expensive layer of most of the layers that we have. So it's about to be 101.6. But one of the things that I want to go home, these small optimization reduce the image size very efficiently, because if I not using this command and move the copy up to the npm install, once it's going to construct everything, and if I update or not update the image, I'm just, if even I just changes the code, it once again installing the npm install. But when we ask them that the package.json file is first in the layer, next to see if there is change in that file or not. It's not file have any updation in that, then it's not installing the npm install packages. But if I remove that layer, so every time you update move the code, it sees the npm packages and it install the npm dependencies for that. So that's going to be really slow down the process of building your containers and managing your containers. So meanwhile, we are trying to use the web app Azure App Service now to web app. So that is a Azure App Service plan we are using for web app containers. That behind the scene that we see Azure App Service plan is initiated, and we able to use that and enable to deploy our application on top of it. So subsequently is a platform as a service offering from Azure. So we already have a Docker demo. Let's name that first Docker demo. So it's pick up. So now we are using Docker containers for that. And if you want our code for that, then we have a select runtime. We have to .NET runtime, ASP.NET Core, Java, Node, we have PHP and Ruby. These are the runtime that give it to you by the Azure App Service plan. But today we are using Docker containers. So these, if you want to deploy your codes on, these are the runtime that give you by the Azure App Service. You just deploy your app, and these runtime gives you the ability to build and deploy your app into the Azure App Service. So today we're using Docker containers. So now let's go to the Docker, and we use that single container, and we need Azure Container Registry. So once our images are loaded properly, and it's loaded now, we see a new Docker demo that is picked up and is tagged by latest. That's we able to see that here. So once it's deployed, so validation is passes, so one review, and when it's created, it's eventually give us a URL where we can see our application running inside an Azure. So it takes some time to build here. So once the next step is that we go to the once the first application is running inside the Azure, the next step we're going to the our code, made some changes, and eventually build a new Docker image out of that, and then deploy it to the Azure again. So I think that the container registry here hosts a repository of images. So whenever they see the new image, it's trigger the webhook and eventually deploy the new image into the Azure App Service plan, and we can see our whole process of DevOps pipeline with Azure Web App, Azure App Service. So repeat the step first. First, we create an image locally, we run, and we see everything working properly. We contain, and next we contain the Azure, created the Azure Container Registry. First, we created the Azure resource group. In that resource group, we created two things. First, Azure Container Registry, Azure App Service, and these are the two things that reside in our Azure is our resource group, and that's Azure App Service give us the URL. There we can see our application is running and working properly or not. So next thing, we have to go into the container setting, and we have to turn on the continuous deployment, which means anytime when I turn on the continuous deployment switch, that is by default is off. When I turn on, it's given the URL. If I want to show, that's a URL hook that is give us, and let's save that. Once I save it, it's given the resource in it's give me the hook that I can use, and it's consistently watching Azure Container Registry if it has new images or new tags available. Once it's detect that, it's pick the new Azure new image and deploy it to the Azure App Service. So once it's on, let's go to the resource group that we have. Now we should have three things inside it. So let's go to the home and going to the resource group. So that's our application running and working inside Azure Container, and hosted our containers are Azure Container Registry, and we are deploy that up onto the Azure App Service. So last thing, very quick here, we go to the container. So now next thing is we make some changes to the code. Let's say we go to the code, and as of this, we have a Twitter account, Discord channel, we have a LinkedIn, we have an Instagram, and from today onward we have a YouTube channel as well. So we make some changes. Now we build the image again, and we tag it latest. So every layer is not going to be changed because it uses we just use updating this image, the copy, and the npm start. The else are using from the cache. That is a layer file system for you, and that the subsequent builds are really faster because you have updating the only layer is changes. It just detected the change from the copy.file where our code is living on, and we make changes. It's updated the changes here. So now the next step is we have to push the new image, and meanwhile when we go to the Azure, So when we go to the Azure Container Registry and into the repositories, we should see a new image, is updated image that already existing, and it have a latest tag in it, and so it says 19.193 site is already existed, and it's now pushed into the Docker Hub, into the Azure Container Registry with the latest tag inside it. So we can see that we have updated right now, and it has new tag updated here is. So now we have to go to the first into the Azure App Service plan, and going to the same app, we could see a new updation. Yeah, we could see in our app. So might be we are not pushing the image as, let's take a look at what image we push here. Might be we pushing this Docker images. So we have two images available. That is latest that we updating 2 minutes ago. That's one. We tag it by latest. So let's say now we want to run locally. What it pick up? So 8080 outside the container, and inside it has 3000, and we have to copy this thing up and paste it in here. So we have to change the port because already I have my first container is running on 8080. Let's say we have to run it by 8081. Go to the UI, and that's the log part of it. So that's our updated image out. You see the updation that's working locally. So let's say we try to push that again. So it's only update the layer because the layers already exist in the Azure. So it's only update the layer that we change. We actually changes the code. So it's updating the layer there. So that's where we are now see new Docker images. Docker push is happening successfully. Go to the container registry. We should see if everything working properly. New updation of our images. So here we see a full Docker flow, DevOps flow of we have updated the full Docker DevOps flow. First we take the images running locally and then deploy the image from local machine to Azure, and when that push is happening, the subsequently when changes the code again, and we build the new Docker image off of that and configure a new container image that push it to the container registry, Azure Container Registry, and then eventually deploy that to the Azure App Service, and then the new updation are coming very quickly. So that's the whole DevOps process for you. And let's say you are, so we have first created a resource group, and go to the resource. We first created the resource group in Azure. In that resource group, we have two things inside of it. First, Azure Container Registry, and then is Azure App Service. So first we created a hosted registry where my images should live, and then we maintain a plan how I can deploy my container into the Azure. For that, I configure Azure App Service plan for that. And then we go to the container setting, and that's a webhook we creating. Every time a new image is created, we have to see a new Docker image is going, a webhook is detected new image, and eventually that deploys to the Docker hub, the first Docker immo Azure App Service that we created, and it eventually deploy a new app. That's the new version of our app, and that is the very old version of our app that's running inside an Azure. And we are so successfully. Let's say we want to do a demo very working fast, and I want to tear it down. Go to the Azure resource and just delete everything. You have to type the Docker demo, and it's eventually deleted everything, and you are going to up back to the normal. So kind of wrap up our session for today. So today we talk about how developers building code inside a Docker images, maintaining a Dockerfile, running inside a container, and then we deploy to the Azure Container Registry, and eventually we go to the Azure App Service. And the whole process is then we deploy and see if we have updated code, updated Docker images, updated Docker container images, deploy into the Azure Container Registry, created a webhook that listen for the new images in the container registry, and deploy to the Azure App Service. So that's the first look of our containers are. So the next step is from state Docker to Azure. We see we're not going even to the Docker visual board dashboard that we see today. We certainly go to the Docker in CLI command and deploying everything from there. So first we deploy Docker log in Azure, is succeeded. Then we create the new context. There's the context call. There we learn about how the Docker context works. For the today, you see I created a Docker context, create ACI, my ACI context. It's detected that my subscription I have in Azure. Now it's created a resource group. If I already have, it detected that. If I doesn't have any created resource group, it created the new one. Then I used to create, I switched to the my new context that I have created. Then I deploy containers into that, deploy the compose or everything, and it's deploy our web app inside it. So that's the whole flow of our app. So then we see how that's now we are running the containers that's living inside the Docker Container Registry, and we're running them locally without going to the Docker Azure board from straight to the from Docker CI. That's a very cool stuff, and that's coming up next. And when that's happened, we ping you, and we definitely want you to join our next session. And if you want to stay up to date on our latest session, going to the community.cncf.io/cloud Islamabad, and you got alerted by as the new events are coming up. So that's the next plan for that, running our from going straight Docker to Azure. So when I first run here, that's where it takes some time, but now it's has more than 2 years, 2 months of this feature that's Docker gave us. So things are going to working properly. And after that, the subsequent series start that I personally love to talk about. That is Azure Container Service. Hopefully by after 2 weeks. So if you like this session, have QA session, comments me in the chat here on YouTube. And if you want to get connected with us, join our Discord channel. We have a team dedicated for you. Let's say you have surprises as your containers moving from developer's machine to the staging to the production. If you have caught up in any kind of a weird situation, there we have a team available for you that going to be very, very enthusiastic about learning and helping people on cloud native technologies. We have a cloud native community channel as well that will show our hosts community.cncf.cloud Islamabad, and we have a LinkedIn and Twitter channel. We throw every good article we see on the internet and helps you get up to speed on cloud native technology. That all the today's we have for the session today of building the cloud native. We first deploy our container locally. We learn how what Azure is, how container is working. When we're deploying the container locally, running inside a Docker command, update it, and then we eventually deploy into the Azure Container Registry. We created a webhook, and that webhook trigger a new release and is deployed to the Azure Container, Azure App Service plan, and that's the whole thing. I think you love this session, and show me in comments what you learned, what I miss, and I love to help you about. So stay soon. We have so much more session coming up. So till then, stay safe and stay healthy. Have a good night, everyone.